Welcome everyone to today's Synergist webinar, Measuring Occupational Noise, an Easier Approach. I'm Kay Bechtold, Managing Editor of The Synergist, the magazine of AIHA. I'd like to thank all of our attendees and especially SKC Inc. for sponsoring today's webinar. Our speakers today are Lucinette Alvarado and Andy Bragg. Lucinette Alvarado is an industrial hygienist certified by ABIH with approximately 14 years of experience in the chemical, manufacturing, steel, and pharmaceutical industries. She currently works as a certified industrial hygienist and technical services manager for SKC Inc. in 84, Pennsylvania. Andy Bragg has been in the industrial hygiene instrumentation field for 29 years. He has technical sales and management experience both in distribution and manufacturing. He has been with SKC for 4 years and is currently the Director of Customer Service and the Technical Sales Representative for the Southeast. Andy has his COHC certification from the Council for Accreditation and Occupational Hearing Conservation. And now I'll turn the presentation over to Lucinette and Andy.
Hello, everyone, and welcome to today's AIHA Noise webinar titled Measuring Occupational Noise, an Easier Approach. I am Lucinette Alvarado.
And I am Andy Bragg. Today we will talk about an easier approach to occupational noise. Noise is a ubiquitous hazard that may be hard to understand at times. However, it is so important to evaluate and implement controls to minimize the noise exposures in the workplace.
Hey Andy, shall we start sharing our colleagues how noise may be easier to assess?
Absolutely. Lucinette, why don't you go ahead and get us started?
Sure. You know, Andy, I've been in the industrial hygiene field for approximately 14 years. I have done hundreds of noise surveys. Also, I had noise courses when I was in school, and man, I must say that at times noise is a hard area to understand.
It really is, especially for those of us that don't perform actual industrial hygiene noise studies on a regular basis like you have. But specifically, what are some of the things that you're referring to, Lucinette?
Well, there's so many challenges presenting when evaluating and understanding noise hazards. You know, the whole theory behind noise, instead of like particulates and vapors and gases, these are waves that behave differently. It's also about those logarithmic mathematical equations, which if you're challenging math like myself, sometimes it may take you some time to understand it. And also the equipment, it may be complicated to handle. So if it is not set up correctly, you may get incorrect results. So maybe with your expertise with hearing conservation, maybe you can help our safety environmental health professionals that are listening today to understand better this ubiquitous hazard. I can provide some input too on how it is done in the field because trust me, I made a lot of mistakes that gave me the opportunity to learn more about noise. So the first thing that we can do and to kind of like break the ice is to define the noise in simple terms. So can you explain that?
Lucinette, I'll do my best to simplify it. Honestly, it really isn't complicated. But as you alluded to earlier, the main issue sometimes is the formulas and even just the terms that are not often used for other applications, only for noise and sound measurement. For example, there's a lot of sampling done to protect people against respiratory hazards, and a lot of them share the same terminology like parts per million or parts per billion or milligrams per meter cubed or back pressure, et cetera, et cetera. But noise monitoring kind of stands alone with its own set of verbiage and terms. So unless you do it on a regular basis, it can be difficult to understand and remember. So I'm going to see if I can simplify it here to those that don't deal with it that much. For those of you that do monitoring noise on a regular basis, like Lucinette has in the past, please bear with me for a couple of moments. Sound is basically something that you can hear and that can be measured if desired. And there are three components needed for sound to occur: a source, a medium, and a detector or a receiver. So for the sake of this explanation, let's use a baby crying for our example of sound and noise. So the source in this example, of course, is the baby crying. The medium, well, for sound, it's air that allows the sound waves to travel. So air is the medium. The detector or the receiver, which is something to hear or measure the sound. For again, this example for us, the receiver is the human ear. So the baby cries, the sound waves travel through the air to the ear, we receive it or hear it, and then we react appropriately. But that's sound. We want to get more specific and talk about noise. Well, noise, in very general terms, is just unwanted sound. So is a baby crying noise? Well, not when first born. It's a miraculous and relieving sound to hear. And maybe 6 weeks later at 3 a.m. in the morning, yeah, well, maybe at that point it's noise. But herein lies the problem. Noise is subjective to the person hearing it. What is noise to some may be music to the ears of others. So in our world of industrial hygiene and safety, we have to get away from this. It can't be subjective. So OSHA defines noise specifically, and that is what we will focus on now when defining noise. And we will spend a little more time on specifics in just a moment. But for now, please just remember that sound, though sometimes it may be annoying or unwanted, may not be OSHA-defined noise unless it is so loud that the decibel level is potentially harmful to one's hearing. And I mentioned decibels there. Again, for those of you that might not do this on a regular basis, decibels, or dB, as you'll hear it referred to, is the unit of measure for sound and noise. So you'll hear that a lot over the next 40 to 45 minutes. An easy phrase that I like to use to separate noise from sound is that we measure sound, but we worry about noise. Sure, the source may be annoying, but the real issue is when it can possibly cause a hearing loss.
That is a great way to define noise, Andy. I remember my days with my boys when they were babies at 3 a.m. in the morning. Oh, man. So now let's see how the human ear handles noise. So this will be like a biology 101 session in a minute or so. So OSHA and other organizations have great explanations on how the ear makes hearing possible. So the ear is divided into 3 sections. So we got the outer ear, the middle ear, and the inner ear. Each section has its own functions. For example, the noise comes in the outer ear and directs it to the eardrum. And then the sound reaches the eardrum as a variation in air pressure. Then the sound is modified to a vibration in the eardrum, which are amplified by the ossicles, which are small bones located in the middle ear, and transmit sound pressure to the inner ear. And then the vibrations are transmitted as a wave energy through the cochlea. And then the mechanical movements of the wave are transferred into the nerve impulses that will travel into the brain, which interprets it as sound. When that sound is considered noise, the whole system gets affected and hearing loss happens. And now that we know how noise can affect our hearing, why is it important to measure noise in the workplace?
Well, that's a loaded question that I could probably talk about for hours alone, but I will summarize as much as possible. In the United States, OSHA gives us guidelines to follow, and then NIOSH and ACGIH give additional guidelines and suggestions to help us protect our employees at the highest level. Yet hearing loss is one of the most common occupational illnesses and legal complaints year in and year out. Some of you may already experience a level of hearing loss. If you are attending this presentation and you are fortunate enough to have very good hearing, you probably know someone personally that doesn't. In more cases than not, when people retire and plan to enjoy their hard-earned time of relaxation, travel, or just time with family and friends, they find that years of hard work and experience to noise and exposure to noise has caused them to lose some of their hearing, and therefore they've lost some of their quality of life as well. Workplace noise injuries and hearing loss occurs over time, and a lot of people don't understand that. It occurs over time. So left to our own devices, It is often human nature to believe that since I can hear fine today, then the noise that I was exposed to yesterday should be just fine. Unfortunately, in the world of noise exposure, you couldn't be farther from the truth. So as a responsible employer, we need to assure that we shoulder the responsibility now so that our employees will appreciate it later, whether they appreciate it today or not. But more importantly, so that they will have a better quality of life for the rest of their life. So unfortunately, we can't control what people do on their own time, but we can control what they do in the workplace and what they're exposed to.
Andy, that is right. We cannot control what people do on their own time, but we can control what they do in the workplace. However, the big question is how we do that. So you will need to identify if exposure is present. And then after determining that there's a noise present, we need to collect initial information. And then we need to perform a noise screening evaluation using a sound level meter. And then perform a noise dosimetry, which is highly recommended to do both the noise screening and the noise dosimetry at the same time. We will discuss each of these steps in more detail. But Andy, will you help us identify if the noise exposure is actually present?
Well, earlier when I attempted to simplify a noise definition for you, I mentioned that OSHA provides specifics on measuring noise and, more importantly, the possibility of overexposure to noise. So now I'm going to give you three very important things to remember that will come back to you 100 times over when you're talking about noise monitoring in the future. You'll see these things written in ways that are extremely confusing, but I'm going to give it to you in the way that my simple mind remembers them. So please write this down if you can. You won't see this on the slide because I'm kind of sneaking this in on Lucinette. So I apologize, Lucinette. Again, for the United States, OSHA's Hearing Conservation Amendment says that all noise above 80 dB must be measured. Now, there's a lot of history behind that, but just again, to simplify it for today, I'm going to leave it at that. Remember that all noise above 80 dB must be measured in regards to noise. Next, 85 dB over 8 hours is considered 50% of the allowable dose. So why do we care about 50% of the dose? Well, this is often referred to also as the action level, or the level at which someone must be included in the mandated hearing protection program. So that's a very important number. Then 90 dB over 8 hours is considered 100% of the allowable dose. This is the permissible exposure limit, or you've heard it called PEL, P-E-L, or the level at which someone cannot be exposed to a higher level during their entire work shift. Anything above this must be engineered out or removed if at all possible. And sometimes it's not, and we'll talk a little bit more about that as well. But if it can be engineered out or removed, that's the level at which it must be. So, probably a simpler way to know if you're experiencing levels of noise exposure to be concerned about, even without a meter or even without the 3 bullets that I just gave you. If you notice in a work area that the employees must yell at each other to communicate, or even just raise their voice to communicate, and they're just standing 2 to 4 feet apart, then they need to be targeted for a noise study. Keep in mind that these high levels of noise can lead to a sense of isolation and annoyance, difficulty concentrating because it is so loud. It lowers morale because people need to be able to communicate at a comfortable level. It also reduces efficiency, and it can also cause fatigue, which can lead to other safety issues if you deal much in the safety world. So as you see in the table on the slide, normal conversation should be somewhere around 60 to 70 dB, depending on the person's voice. Classroom chatter, which can be quite annoying, is only at 70 dB or more. OSHA used a 5 dB exchange rate, or in other words, noise doubles every 5 dB. So keeping that in mind, if a freight train is 80 dB at 100 feet away, and you're measuring levels around 85 dB in your work environment, then that gives you an idea of how loud it must seem to that employee. If that is the case, then you definitely have a considerable noise exposure present. So Lucinette, after we make that determination that there is noise exposure present, what type of information needs to be collected?
Hey Andy, it is important that you collect and be familiarized with critical information, and some of them, these type of information are the applicable noise regulations. Depending on the country, any region, and company, you should read and be familiarized with the applicable standards. And you mentioned some from the U.S. OSHA, like for example, when we talk about the OSHA, it's under the general industry, which is the 29 CFR 1910.95. There's also one for the construction industry, which is the 29 CFR 1926.52. Also, ACGIH has noise threshold limit values, or TLVs, and NIOSH has also recommended exposure limits, and we cannot forget the Mine Safety and Health Administration, MSHA, which also have noise guidelines. OSHA is the commonly used in the industry. However, specifically companies adopt the guidelines from ACGIH and NIOSH just because they're more conservative. We also need to pay attention to the noise sources. Like, you need to conduct a walk around evaluation. You need to go out there and you need to identify the sources of noise, identify any equipment, any task that is causing that elevated noise level. That also may help to establish those engineering controls, as you said. The job conditions. This refers to how the worker is performing the job. If the employee is using hand tools that are causing the elevated noise, is the employee working around an area that is producing a high noise, and you mentioned like railroads or horns, etc. This is important to note as well. And last but not least, previous surveys. Like, this is important to review too, because it will give us a history of what has happened in the area in terms of if there has been any work done to minimize exposure. If there's no information available, then this is your responsibility and a good opportunity too to perform baseline monitoring and establish an action plan. So Annie, we need to do a noise screening and noise dosimetry, and at times it is difficult to identify which equipment to use, like a sound level meter versus a noise dosimeter. Can you explain the differences between them and how we can use this equipment to our advantage?
Sure. This is where people can certainly get a little confused, but it really is simple if you can kind of visualize it. So I really want to make sure that you grasp this. So again, I apologize if it seems too elementary, but I really want to make sure that it's clear. A sound level meter measures sound. And I know you're thinking, duh, but remember this, sound measurement includes noise. So with a sound level meter, we don't really care about if it's considered noise or sound. We are measuring everything that can be heard and measured. So we aren't looking for noise issues. We are looking at all sound. Remember that, because it will come in handy in a moment when we talk about noise. Sound level meters are handheld and normally larger, and that's a big giveaway. People get confused when you talk about dosimeters and sound level meters, but sound level meters are larger and they're handheld. They usually have a larger display because the operator is normally viewing the screen real time as they walk around and perform surveys in a facility. So since they are normally being used for spot checking or doing a building walkthrough that Lucy alluded to earlier, the battery run times are normally shorter because a brighter, bigger screen with a backlight is often more important than having longer run times. So now, noise dosimeters measure what? Yes, you're right, noise. Noise dosimeters are designed to hear and record what the human ear is hearing with regards to noise that could potentially be damaging to your hearing. So its job is to measure noise exposure to the employee. Therefore, it is very small, especially by comparison to a sound level meter, and it is designed to be worn on the shoulder. Now, this display is usually much smaller because the operator is not necessarily worried about reading it during the operation. They would normally take the unit and download it to their computer through software after the fact, and then get all the data information they need either from the screen at that time, which is possible, or through the computer software. Therefore, dosimeters must have full data logging capabilities that can collect data for an entire work shift, whether that work shift be 8 hours, 10 hours, or even sometimes 12-hour shifts. So they normally use a rechargeable battery that can run much longer than a sound level meter. One of the most important requirements of a dosimeter is that it be as unintrusive to the subject as possible when being worn for 8+ hours. And another great feature is that dosimeters today do all that confusing math that Lucinette discussed earlier. So you and I no longer have to do any of it unless you just really enjoy math. The dosimeter will do that for you. So Lucinette, now that we have given the background in easy terms about noise and how to evaluate it, let's put it into the perspective of an OEHS professional. And since you've been in the field for about 14 years, why don't you handle that part for us? Because it would be a lot more clear from your perspective.
Sure, Andy. Now we're gonna go and do the fun part and apply all these concepts in the field, right? So you can see me there in a railroad. Yeah, that was me. Okay, so the first thing I want to discuss with everybody is which equipment to use. That is one of the biggest questions an OAHS professional asks. There's so many types of sound level meters and noise dosimeters that from different manufacturers, and it's hard to select one. As an OHS professional, I have some criteria, and I am a little bit picky about this. So when selecting a sound level meter or a noise dosimeter, I look for clear, well-lit screen to see the data. I have been in the dark areas such as steel mills during midnight shifts, and trust me, if you do not have a well-lit screen, it is hard to see the data. Also, navigations and controls that allow quick, easy, and accurate set of measurement parameters. The less button sequence to press and the easier to get to one screen measurement to another, it will be so much better. While you're on the field, you're on the clock. Like you need to be right there, ready when obtaining a reading for a specific task or area. Also, you will look very bad if you do not understand the sound level meter on the instrument overall in front of a plant manager, or if you're a consultant with a client at that time. And then also easy and accurate calibration. Again, you're on a time crunch, so you need to go calibrate quick to put the noise dosimeter on the employees that will be monitored. And then when I do noise dosimeters and any sampling whatsoever, I am right there before the employee starts their shift. Once I put the device on the employee's hearing zone in this case, they are on the go. So you have to like accommodate their time to your time. And then for noise dosimeters, if they have a secure shoulder mounting, will be great. The employees are doing tasks, and if the noise dosimeter is not secure, you may lose a unit, and that will not be pretty because they're not necessarily super cheap. So a large display on the noise dosimeter also helps see the noise results in the field. If the screen is too small, you may need a magnifying glass to look at the numbers. So also you may incorrectly read the results, especially during that midnight shift that I talked about at a steel mill. So Andy, I have so many stories that I can share with everybody, but we have limited time. So can you talk about the importance of the instrument setup for both the sound level meter and the noise dosimeter?
Absolutely. This is really important because, as Lucinette alluded to, you don't want to go out and bother an employee and put a dosimeter on someone for 8-10 hours and then come back and find out that the settings were incorrect and you have to go start all over again or try to do it again the next day. So on this screen, you'll see several different parameters that are selectable by checkboxes or using a drop-down menu or some sort of multiple choice selections. And there's many different options. This is just one example. You may not be familiar with all of these terms, and what is important is that you be sure that you have the correct one selected before doing your survey or your walkthrough. It's extremely important. And they all can be different. Not all applications are the same. Therefore, your settings requirements may be different from time to time. In most cases, once you collect the data, you cannot go back and change it after the fact. So you may have to repeat the monitoring session, as I stated earlier, if your settings were not correct. Now, Lucinette's going to talk a little bit later about some exceptions to that, but that is the case normally. If your sound level meter requires that you set a specific range, and there are several that require that, you need to make sure that you set it for the sound that you're going to be listening to most of the time. So, for example, if your unit is set for a range, let's say 0 to 70 dB, but your sound that you're listening for most of the time or you're measuring is over 70 or 80 dB, then your data will not be correct. If you are taking a measurement that is required to be taken with C weighting and a 3 dB exchange rate for some reason, but the sound level meter is set for A weighting and a 5 dB exchange rate, then you will again have to repeat that sampling session because the outcome will not be the same. Especially with a sound level meter, always be sure that you know your battery life and how long you need to measure. As I mentioned earlier, sound level meters will not normally measure as long as 8 or 10 or 12-hour shifts. They're really just designed for shorter term spot checks. So everything I just stated is somewhat more important with a noise dosimeter because you will be putting this on an employee to be worn for an extended period of time. Fortunately, as is the case with the software setup that you see on the screen, some dosimeters allow you just to select the regulations that you are trying to meet, and the dosimeter does the rest. So at the bottom of the screen, you will see the white header shows that this dosimeter is currently set up with 4 internal virtual dosimeters. That means 4 different sets of parameters that it's going to be measuring all at one time. And they have selected, or the user has selected, the OSHA hearing conservation parameter, the OSHA PEL parameter, MSHA hearing conservation, and then ACGIH as well. Now, I know that it isn't very likely that someone would be using these 4 specific settings simultaneously, but it's just for illustration purposes to show the possible options. So in this case, you don't have to worry about the correct settings. They have been pre-programmed for you. However, I would highly recommend you check them out and make sure they're correct in accordance to what your expectation is the first time you use it. Some sound level meters and dosimeters can be set up to start and stop at preset times. So always take the time to learn the instrument and all of its capabilities, like Lucinette mentioned earlier. Features like auto starting and stopping can be huge value to someone that's sampling multiple people in different areas. So then comes the importance of calibration. And Lucinette, based on your experience, can you walk us through how important calibration is and what things we need to consider?
Yes, Andy. Both the sound level meter and the noise dosimeter need to be pre and post calibrated. The calibration is to confirm that the instrument is functioning properly on the days used and prove that it is still registering sound levels correctly at the end of the day. Like pre and post calibrations also confirm any changes in temperature or humidity have not affected the instrument's accuracy. So each instrument model is calibrated in a slightly different manner, but the general process follows the basic standard steps. The typically daily pre-use calibration involves like setting up the instrument for use. So you turn it on, the electronic calibrator and the noise measuring instrument to allow them to kind of like warm up. Then you check the calibration and instrument battery charge. And yes, please check that. At times we overestimate the battery, and at the time we were like, oh no, we need to charge this. So please check that. Test the instruments with that standard tone of known pitch and intensity produced by the calibrator. Typically, it's like a 114 dB and 1000 hertz. That's how typically, as I said, the noise calibrator is set up. However, it depends on the noise parameters and also depends on the noise standards for that specific region or country. So checking also the instrument reading during the test and making minor adjustments to the instrument if necessary. Nowadays, the technology allows units to readjust, which makes it an easier calibration. Oh, yes. So then you need to document the calibration results. That's important too. And both the sound level meter and the noise dosimeters need an annual calibration by the manufacturer to assure the unit is within specs. And it's very important at times they're missed, especially the noise dosimeters. So remember that this information is important, believe it or not, especially if the noise data obtained goes into court. Like you will need the calibration data and allocated certificates just to justify the performance of the noise equipment. I mean, you may think that you don't need it because the calibration doesn't rely on calculating the volume, as in the case of air sampling. However, it is crucial to check the instrument's performance. So Andy, now that we calibrated and performed the noise survey and dosimetry, how we can say that our data makes sense?
That's a very good question. Sometimes we get so carried away looking at the numbers from a record keeping perspective that we forget to stop and just say, do these numbers even make sense? We will talk in a moment about employees possibly tampering or playing around with dosimeters out of curiosity or sometimes out of spite. But that aside, there may be something odd happening to your instrument, or possibly it just wasn't used correctly. There are simple things that you can look at for with a sound level meter or a noise dosimeter. For example, if you're taking a measurement with a sound level meter and something just doesn't look right, maybe the sound seems much louder than the readings that you're getting on your sound level meter. If you double your distance from the sound source, and let's say you were at 3 feet and you step back to 6 feet, the sound pressure level should drop by approximately 6 dB. If you double that distance again, so now you go from 6 feet to 12 feet, the reading should drop approximately 6 dB again. Now, that's based on a Z weighting scale, or unweighted basically. So if you are set for a C or A weighting, it may vary a little bit, won't be exactly 6 dB, but it will still give you a good idea, and it should still be proportionate. So if it doesn't drop proportionately to the distance from the source, then you may have something wrong with the meter or the microphone, or you could have the range improperly set in the meter. And there are times that a meter might calibrate, but then you get out in the field and it doesn't operate correctly. So you really have to pay attention to that as well. And just for information, the reduction of sound based on the doubling of distance is known as the inverse square law in acoustics. And you may have seen that before, and you may hear of it again. Now, on a noise dosimeter, if you know, based on what we said earlier, that you have to talk very loudly or even yell to communicate in an area, yet when you get your data from a dosimeter that was used in that area, and the TWA is less than 80 dB, or the dose is extremely low, something like 20%, this should be a red flag that something is not right. This could be intentional by the subject wearing the unit, or maybe taking it off or covering it up, or it could be that the settings are just not right in the unit, or even that the calibration was not performed correctly. Regardless of which type of monitor you're using, be sure to use common sense to look at the overall numbers and make sure that something doesn't just seem off. There are some great terms and information in the OSHA technical manual, like this graph about the inverse square law. I would encourage you to go to the site and select the noise option. You'll find plenty of great support materials there. Lucinette, I would imagine that you have had several situations where the data that you have collected didn't seem to make sense. If you already did your sampling and were at the point of reviewing that data, and you discovered that the dosimeter was not set correctly, and it was too late to go back and do the survey again, is there any way to save or convert that data?
Andy, I can share so many stories where my data did not make sense compared to the sound level readings. And it was too late since I traveled back from the field to my office. That happens during the beginnings of my career, and truly it was very, very nerve-wracking. However, there was light at the end of the tunnel. It wasn't the most perfect scenario, but there's a way to get a projected time weighted average TWA based on the sound level reading. So going back to school using the formulas provided by OSHA, if you have periodic sound level meter readings obtained throughout the shift and have records of the time the employees performed the task, you can use the time and the sound level to calculate the dose. So OSHA provides more specifics on the variables of the equation, as you can see on the screen. Once you calculate the dose, you can use the TWA formula, or if you are in a hurry, you can also use the conversion table that OSHA also provides in their website. And there you go. You may breathe. It is a matter of explaining what happened whenever you put those posting tables or your report together, and you have to put a note that that TWA was calculated based on the observations obtained during the survey. But it's also a good practice every so often to check the math behind the noise, especially like if you are uncertain, as you alluded in the previous slides about, does my data make sense? Just do the math and see the differences between the two, the calculated versus the one that we got in the instrument. So because we rely so much in technology nowadays, that we forget that this information, like the manual calculation, is available as well. So Andy, I'm going to switch gears a little here. So we're going to talk about the Octave. This is something that I have always have trouble understanding. So can you tell us about it in simple terms?
Yes, I can. This is definitely another area that a lot of people are intimidated by, yet it is something that is very useful. And it's not as complicated as people think. Sometimes, again, the numbers and the terminology get intimidated. But when I first got into noise and sound instrumentation business, a person told me to think of the overall sound pressure level or the sound level as a pie, and to think about the frequencies or the octave bands. These were all the pieces that made up the pie. And that's a really simple and maybe not an exact analogy, but it really did help me understand that this is not something separate or something that must be added to or subtracted from the sound level. These are what make up the sound level. And these are the things, all the different pieces of the pie, again, if you will. Sometimes all you need is an overall sound level. But if you're taking a measurement to determine what type of noise reduction equipment or noise treatment to use, or if you're trying to determine which hearing protection is best to use, then you will need to know the frequency that has the highest reading as part of the overall sound level. Normal octave band measurements are taken from 16 hertz frequency up to 16,000 hertz. There are variations of this based on the meter that you're using and whether that you're using full octave band or 1/3 octave band settings. And I don't want to confuse things at this point, but just store that in the back of your mind, because that may come up when you get into doing octave band measurements. Really, the difference between full octave and 1/3 octave is those pieces of the pie that I talked about get smaller, and you have more readings to evaluate and to analyze. In this illustration you see on the slide, there is a bar graph up at the top display, and then there's a digital readout on the bottom. Some meters offer these two options. Both are nice for different reasons. The bar graph helps you see at a glance which frequency is giving the highest readings at that moment. Unfortunately, it doesn't really give you an exact number. You're just looking at a bar bouncing up and down, but again, it tells you which one to focus on. The digital display will provide exact numbers, but it can be hard to follow when the numbers are changing all the time in the field. So it really comes in handy to have the bar graph in the field, and then when you're actually looking at the data after the fact, the digital information is valuable. The sound level reading in this example on the screen is only 61.5 dB, or 61.5 dB, so it really isn't a problem. But still, you can see that the 31.5 hertz range is the highest reading octave band. So if this were a louder or higher decibel measurement and you were trying to figure out the source, the 31.5 hertz would be the one that you address first. That would be where you would focus. Believe it or not, you can actually amplify sound if you surround it with the wrong material. So knowing the frequency of the problem is imperative. You can't just find out the sound pressure level measurement and then go out and wrap it than some type of material because you can truly amplify it like a speaker. As I mentioned earlier, you can see here that all these numbers come together and form the 61.5 total sound pressure level reading. A little insight into the future of octave bands or octave filters. A recent change in the industry is that you will see now that octave band capabilities are on noise dosimeters as well. This once was only on sound level meters, but now you'll see it on noise dosimeters as well. So Lucinette, you shared some field experiences earlier, and I spoke briefly about employees potentially affecting their readings during a survey. Do you have any situations that you can remember where employees affected your monitoring session?
Yes, Andy, but before I get into that, thank you for explaining the Octoband. Like, now I'm hungry. I want a pie. But using the pie as an analogy, that makes more sense, at least to me. So I hope to the audience too. Yes. So as you said, I can write a book sharing my field experiences. When doing noise surveys, you have to take care of the noise equipment as well as the employees who are wearing it. At times, employees are concerned about the survey and the instrument. So there's some of the things that may happen on the field. So the biggest or the main question that they ask is that if they're being recorded. They get so nervous about that. So if you're transparent, it's just the key for a successful survey. So if you explain to them that the instrument will not record, they will feel more comfortable wearing it. Actually, they will make jokes about it. So it makes it like better during the day for them. So the noise dosimeter should always be put within the hearing zone of the employee. Since you cannot clip it on the employee's earlobe because it's going to hurt, put it in the collar area. That's considered the hearing zone area according to OSHA. So also it's important to consider to record which side you place the dosimeter, either the left side or the right side of the collar. At times, you may get some variations in the results depending on how the employee is performing the task. Then the noise dosimeter should always be placed outside the personal protective equipment or the PPE. And it's important that you do periodic monitoring, and I highly recommend it. It's just to verify that the employees did not hide the unit underneath the clothing or the PPE. And then sometimes the employees get scared of having a high exposure that they do what they can to minimize this exposure. And trust me, they can be very creative. And talking about creativity, the employees get very curious about the noise dosimeters. Since it's something that they don't wear on a daily basis, they want to press the buttons to see what happens. Fortunately, the noise dosimeters nowadays are capable of locking the screen so it cannot be tampered. Sometimes talking about if the data makes sense, you get these unusual situations where you are in a position where you need to apply your professional ethics and experience. Some of the examples are like employees refuses to wear the noise dosimeter. Many times that's being handled by the actual company, or if you're like a consultant, like you address that and they will take care of it. Your client. The noise exposure result does not make sense, as we explained before, Andy did. And in this case, it may be because of an unusual task that the employee did. And yes, I'm going to put an example here, singing inside a cabin. And yes, that can happen. Like singing or radio or like music radio, those type of things. So that also the employee is scared of the noise result and hides it somewhere at the facility. And yes, this could happen too. This could sound odd, but I've experienced it. Like employees think that the unit is speaking to them. And also, there are other moments that you may think currently right now, and right now you may either laugh or cry or both. um, so Andy, I can keep going, sharing many stories here, but we need to keep going. So what to do with the data that we obtained?
This could be an entire 1 hour presentation on its own, so I'm going to do my best to summarize. But simply put, remember, our goal is to protect the worker. In doing that, we have to know what is most effective and what is least effective. So in this hierarchy of controls pyramid that you see, elimination or substitution are by far the most effective methods of protecting against hearing loss. So when you get the data and you've got a area or a sound/noise source that is so loud that you have to address it, eliminating it altogether or replacing it with something quieter is the best possible effect. However, I realize that's easier said than done. If done in the design stage of a facility, this is usually possible, but in an existing facility, it becomes cost prohibitive. So this is the goal, but not always realistic. So then we move to engineering controls, and these are preferred over administrative controls because this method of taking the noise source out of the picture, and therefore it doesn't depend on employees making the decision or on the cost and practice of wearing PPE like earplugs or earmuffs. But you have to be able to use some sort of engineering method to enclose the sound or isolate the equipment to reduce the sound. This is where, going back to the Octave bands, this is where Octave band filters come into play and will help determine if this is even possible. So then, if that's not possible, we move into administrative controls and PPE, or personal protective equipment. And these are probably the most frequently used because they are more realistic with regards to treating the noise hazards that are not otherwise controlled very well. Establishing practices where workers are only allowed to be in a noisy area for a certain amount of time, or providing them with the proper hearing protection, all looks really good on paper, but these are the least effective because it doesn't treat the noise hazard directly, and it requires significant effort and discipline by the workers in the area to reduce their own exposure. So, Lucinette, if we talk about PPE, or the personal protective equipment, being at the bottom of the hierarchy of controls pyramid, how important is it to select the correct PPE for noise?
Well, Andy, that is a great question. We're not going to talk much about PPEs, and it takes an additional day to talk about it, honestly. So this is a quick summary. The personal protective equipment would utilize for noise reduction, and everybody should know this, it's called hearing protection devices, or HPDs. So the hearing protection devices are generally used during the times it takes to implement engineering or administrative controls, or when such controls are not feasible. Unless great care is taken in establishing a hearing conservation program, workers will often receive very little benefit from the hearing protection devices. The best hearing protector, when fitted correctly, is one that is accepted by the worker and also worn properly. If the worker exposure is about 85 dBA on an 8-hour time weighted average, the hearing protection must be made available along with the other requirements in the hearing protection program. Unfortunately, there are fit testing systems that confirm that the hearing protection devices fit. As a rule of thumb, you may use the noise reduction rate formula presented on the slide to confirm if the hearing protection device is suitable for that job. So it will just give you a pretty good idea on what type of hearing protection devices employee will need on a particular area and or task. However, depends on the situation. You have to, like, the PPE is at the bottom of the hierarchy of controls, as you explained before. So the OHS professionals should investigate the feasibility of the top areas of this pyramid before, just to make sure that we follow that accordingly.
Listen, that we're quickly running out of time. So I hope and I think that we covered the basics for noise measurement.
Yes, I hope this information provides easy ways to follow, like to follow a noise survey and gives you a different perspective. Like, noise measurement is easier than you think.
It really can be. And I hope this helps. And we really thank you very much for your attendance and for your attention.
Yes, I also want to thank the AIHA for giving us the opportunity to participate in this webinar.
So at this point, I guess we'll jump into the Q&A and ask if there are some questions for us.
Yes. Here am I.
Okay, great. Thank you. Thanks, Lucinette and Andy. It looks like we have about 9 or 10 minutes left for questions. Just a reminder, if you'd like to ask a question, please type it into the chat window on the right side of your screen and send to everyone. The first question I have for you all comes from Aaron, who asks, why do different jurisdictions use different criteria to determine what overexposure is over 8 hours? Many jurisdictions in Canada use 85 dBA as an 8-hour occupational exposure limit with a 3 dB doubling rate. What is the difference?
You want to take that one, Andy?
Oh, yeah, that is a great question. It really is. And Aaron, I think that you're probably asking a question that many of us have asked time and time again. And I think at the end of the day, and this is not going to be a very scientific question, and maybe we can address it in a better way and send out the response. But at the end of the day, I think everybody is trying to establish what is the best method, what is the best technology, whether it be, is it 4 dB, is it 5 dB, is it 3 dB? And at the same time, do it in a way that's feasible for the employer, to where, employers don't go out of business trying to adjust. So you take all of that together and the advancement in science. And I think that people just settle on things differently. And I think at this point, it seems to be centered around countries, as you alluded to. And that's kind of where we are. I hope that at some point in time, we all get on the same page. We all use the same exchange rate. But I think I can honestly say it is in an attempt to do what is best. And as you know, sometimes people have differing opinions on what is best. So I'm sorry that's not a direct question, but Lucinette, do you have anything to add to that?
Yeah, and also I think it's also like probably different countries applies to the physics behind the noise, and they just depends on which country you're talking about. They apply as a conservative approach. But Andy is right. Like if we can come up, with an agreement of just one parameter, for example, that everybody can follow, it will be so much easier for everyone. So yeah, I hope that answers the question at least a little bit.
Great, thank you. There was some discussion in the chat about this, but I have a question from Megan, who asks if you all have any recommended dosimeter models.
Yes, I definitely do. But I want to be real careful there. That's a great question, and there's some good choices out there. SKC has a dosimeter, the noise check, and that is certainly the instrument that I would recommend. We're very proud of it, but I don't want to make this into a sales pitch either. So I would certainly, you can contact me offline and we can talk about it, but that would be my recommendation.
Okay, great, thanks. The next question I have is, are there any good sound level meter survey data sheets or spreadsheet templates?
Well, to answer that question, you may refer to the OSHA website. Typically, they provide some templates as a guidance, but there's not like a unique format to it, because it depends on what you want to get, and I can give you pointers. Like, it should have the employee information. It should have areas where you can manually put the data. And also it should have areas where, any engineering controls are in place, the hearing protection devices, and also another area where you can track the pre-post calibration. And last but not least, an area when you can record like when the dosimeter was turning on, turning off, and a space where you can put observations on what happened that day, and also a space within that observation to put the sound level meter reading. And that's kind of like, you use that as a backup in case something goes whack on on the noise dosimeter, for example.
Okay, great, thank you. The next question I have is, Is there a way to address a worker who says they are sensitive to higher frequencies?
That's a very good question. That's where you use your professional judgment. And I think when that happens, you should always contact your contact if you're a consultant or if you're the actual EHS person within the facility. You talk to the employee and if that's the case, then maybe there's another employee that are doing the same task. If not, then you have to like plan out how to handle the situation. It depends on the case.
And I want to add something to that. I don't want to oversimplify this because I know there are certainly certain situations, but
Hmm.
the nice thing is there's technology today, as we talked about the octave band frequencies earlier. There's the ability to take the measurements, and if they're really sensitive to high frequencies in an area, there is much better hearing protection available today that could be really targeted to knocking out those high frequencies, even if it's not necessarily a high noise area. Maybe it's a pretty safe zone as far as the noise levels, but you could have them wear earmuffs or hearing protection that specifically goes after those high frequencies to make their work environment better and more conducive to their issue.
Yeah.
Okay, great. Thank you. The next question I have is, should the dissimitar on the collar be on a certain side depending on if the wearer is right-handed or left-handed?
It's not much of a if the employee is right-handed or left-handed, although you can follow that. It's more of like, the work area, like where the noise sources are coming from. From my experience, I've done like side by side, meaning like two dosimeters in one person, one on the left and one on the side. And depends on what the employee is doing, you may get like some type of difference. Depends on the situation, like from a 3 dB or 5 dB difference. So it's typically handled when you're handling like a court case. They ask about that. So it's good if you, whenever you're doing your noise survey, just write down on which side you're putting it, just in case it gets questioned.
Okay, great. Thank you. The next question I have is, what does, I think, LAEQ mean, and what is the minimum or industry recommended measuring time for taking a sample of a noise source to compare to an 8-hour TWA?
So Andy, you can answer the first question. I can answer the second one.
Sure.
Because you define this better than me, honestly.
There is, we do some physics of sound, physics of noise seminars that talk about things like LEQ and L average and TWA in more depth. So that's a great question because it is confusing. But depending on the setting of the sound level meter or the dosimeter, basically L average, or your question, LEQ, becomes the average of the sound over the time that has been running when it's less than 8 hours, because a lot of what we do is based on dose or based on TWA, which is not a complete value until 8 hours. So LEQ gives you that number before 8 hours that you can kind of gauge where you are. So and on some meters today, you'll see a number that's called projected TWA, and that will be a similar number. But that is basically the running average that you can look at and associate with until you get to that 8 hours.
Yeah, and answering to the second question, since it's a 8-hour TWA for the OSHA PEL, you should be doing the monitoring as close to that as possible. Um, we don't need volumes, of course, but since it's based on that, if it like there's other other countries also have based on 10-hour, 12-hour, even in the US, so you have to follow if it's based on what time range, so that you will get the dose and the TWA based on that time, if that makes sense.
Okay, great. Yeah, I think that made sense to me. Unfortunately, that's all the time we have for today. I saw a bunch of other questions come in. I just wanted to let everyone know that we will be forwarding all your questions along to SKC Inc. So that they'll be able to get back to everyone, hopefully. I apologize for not being able to get to everyone, but we've got lots of questions. So I wanted to go ahead and wrap things up. My thanks to Lucinette Alvarado and Andy Bragg for their presentation, to SKC Inc. for sponsoring today's webinar, and to all of our participants. I wanted to let everyone know that registration is already open for one Synergist webinar event happening in June. On June 15th, Draeger will present a product demo of the Draeger Exact 7000 multi-gas detector. Thanks to everyone again, and hope you all have a great day.
Thank you very much.
Thank you, everyone.
All right, this was great. Thank you, everyone. This actually concludes today's webcast. Thank you all for attending. The recording will be available at aiha.webvent.tv, and we will send all registrants an email tomorrow with this link. And please visit our event calendar to sign up for future webcasts.